For today's notes, what we're doing is we are taking our radicals that we worked with last time, and we're going to actually solve equations involving them now. So we're not just going to be simplifying our radicals like we did last time. We're actually going to be solving equations where radicals are involved. So our steps for solving those is you want to first isolate your radical. If there's two, separate them. Meaning you want one on one side of the equal sign, you want the other one on the other side of the equal sign. You do not want two radicals on the same side. Second step, you're either going to square or cube both sides of your equal sign. And then third step, you're going to solve and check your answers. Always want to check, because a lot of times what's going to end up happening is we're going to get a lot of extraneous answers when it comes to our radical equations. So we've got to make sure we go back and check. So let's take a look at our first example here. We have one radical sign, we have our cube root of 3 here. So we're trying to solve for x, that is our ultimate goal. So first thing I'm going to do is I'm going to take my 1, I'm going to move it over to the other side of the equal sign by subtracting it. So that's how I get the cube root of x minus 2 equals 3. So now my radical is isolated. So since it's a cube root, I need to cube both sides of my equal sign, because that cube root and then cubing the side, those cancel each other out, so then we're left with x minus 2. And then 3 to the third power is 27. So then my last step here to solve for x would just be to add my 2 over to the other side, so we get x equals 29. So then what we need to do is we need to go and check. So if I go back to the original equation and plug in 29, we got to see if this works out. So 29 minus 2 gives me a 27. Cube root of 27 is 3. So when I add 1 to it, 4 equals 4. It works. So that one's correct. An example like number 2, I have two radical signs. So what I need to do is I need to take this one and I need to move it to the other side of my equal sign. So to do that, I would add it over. So that's why I have positive 2 times the square root of x plus 8. So now we've isolated the radicals. We need to square both sides, because these ones are square roots as opposed to our cube root in example number 1. So we would square both sides. So 3 squared would give me 9. And then our radical goes away, because squaring the radical cancels it out. And then over here on my right side, 2 squared gives me a 4. And again, my radical sign gets canceled out, so I have just x plus 8. So now we'll do our distributive property on both sides of our equal sign. I'll get my x's together, get my numbers together, and then divide by 5, so x equals 10. So again, I need to go back up and I need to do a check. So I go back into the original equation, plug in a 10, see if that equals a 0. So this gives me 3 square root of 8 minus 2 square root of 18. So I need to reduce these. The perfect square that goes into 8 is a 4. And the perfect square that goes into 18 is a 9. So 4 comes out as a 2, but times that 3 gives me a 6. 9 comes out as a 3, but times the 2 gives me a 6. So 6 radical 2 minus 6 radical 2 is a 0. So 0 equals 0. That one works. So in our next example here, again we have our radical 2 square root of x plus 1 equals x minus 2. So example number 4, we actually have a little bit of a typo. So we just need to fix this. This was supposed to be the radical 2x minus 1. It was all supposed to be underneath. So here what we're going to do is we're going to square both sides. So on our left side we get 2x minus 1 equals. Now over here on the right side, a lot of people still mess this up when you have a binomial squared. you have to remember it's x minus 2 times x minus 2. You've got to write it twice and do your distribution. So this ends up giving us x squared minus 4x plus 4. So then I'm going to bring everything over here from the left side over to the right side so that I'm left with a 0. So that means I subtract my 2x, add my 1, so that's how I get my negative 6x and my plus 5. So then we're going to go ahead and factor x minus 5, x minus 1. Once you set them both equal to 0, we get a 5 and a 1. So we need to go back and check these. So do our check. So I'm going to go ahead and I'm going to plug in my 5 first. So when I do 2 times 5, that's how I get my 10 minus 1. So that gives me 9. Square root of 9 is 3. So 3 does in fact equal 3. So that one works. So let's go ahead and plug in our 1. So this gives me 2 minus 1 equals 1 minus 2. So I get 1 equals negative 1, which is not true. So this answer is extraneous. So then over here in example number 5, again, isolate our radical. So I'm going to subtract my 4 over. So that gives me a negative 12. I'm going to go ahead and square both sides. So I get 9 times 6 minus x equals 144. And then distribute my 9. Subtract my 54 over. And then divide by my negative 9. So x equals negative 10 for that one. So now we're going to go through, do our check. Now be careful, when you plug that 10 in, you make it minus a negative, which remember that means we're adding. So this becomes 16, which is square root of 16 is a 4. 4 times the 3 gives us a 12. So I get 16 equals negative 8, which it actually does not. So this is extraneous. Now the reason why this is extraneous is because these two parts of the graphs would not touch each other. So if we tried graphing this, we're going to go through and we're going to type this part into y1 in our graphing calculators and this part into our y2. We go to our calculator, 3 square root of 6 minus x. Make sure you leave the radical, and plus a 4. And our y2 is a negative 8. So then if we look at the graph of it, we can see here's our radical, here's our negative 8. They never actually intersect with each other, so there's no solution for that. The number we got is an extraneous solution for that reason. So why is the answer that you got not the solution? Because the two graphs never intersect. And again, we should, since it says show check graphically, we should draw a little picture. Here's our negative 8. Here's our radical. They never actually crossed each other. So if you were to go back and actually type in any of these examples into your calculator, you would see where they would cross. These ones would cross where x is 29. This one where x is 10. Here where x is 5, but not where x is equal to 1. So you would see all those different points in there. So using your graphing calculator to solve or check a radical equation, we got the steps all filled in for you right there. So let's try this first one. Under y1, we're going to type in 2x minus 8. Under y2, we're going to type in 2 square root of 2x minus 8. So let's go ahead and do that. So I'll go back to my y equals, clear out what I had. So 2x minus 8. And then the square root of 2 square root 2x minus 8. So we've got our two equations in there. So let's take a look at the graph of it. So here's our line. Here's our radical. We can tell in this area right here, they're definitely going to cross. So what we can do is we can go to the calculate, which would be second trace, and we want to look for their intersection, which is right here, choice 5. If you do that, it asks you for the first curve. So if you see right down here, our blinky guy's on the first line. We're good. And then it asks you for the second curve. You got to find where your blinky guy is. Oh, I think I just saw him. Where'd he go? There he is. I knew he'd show up. So he's over there in our radical. Hit enter. Yes, you just hit enter. And it tells you it intersects where x is 6 and y is 4. Another way we could do it is you could look at your table. As you see, we got a whole bunch of errors where they're radical. You can't have values at those points in time. But if you keep going down, we also have a second intersection point where x is 4, they're both at a 0. And then where x is 6, they're both at a 4. So we actually have two answers for these ones. It would be where x is 6 and where x is 4. And if you're solving it graphically, you should always kind of sketch yourself a little picture here. So there's our y1. Since I labeled these over here as y1, y2, I can do that. There's my y2. So there's our 2 points of intersection at 6 and 4. So now here's another example of different kind of radical problems. This one's a little bit more of a challenging kind of problem. So again, like we said in our directions before, you want to isolate your radicals. So you want to subtract this one over. So I get square root of x minus 3 equals 4 minus the radical of x plus 5. And then we still, again, doing the same steps, squaring both sides. Left side is much easier to square than the other side, because remember, that's 4 minus radical x plus 5 times 4 minus radical x plus 5. So we have to do our distribution here. So we get 16 minus 4 square root of x plus 5 minus 4 square root of x plus 5. And then those cancel each other out, so we're left with x plus 5. So then cleaning up my like terms over here, I get a minus 8 radical x plus 5 plus x plus 5. So I want to get my x's together, so I'm going to subtract this x over, but in doing so, it actually cancels on both sides. And then when I combine my 16 and my 5, I get a 21. So then I'm going to subtract my 21 over, and I get a negative 24 equals 8 radical x plus 5. And a lot of times I get kids at this point who ask me, well, why can't I divide by 8? Right here you could. You could divide by 8, and you would get negative 3 equals the square root of x plus 5. So then when we square again, it makes your squaring a little bit easier. So we get 9 equals x plus 5. Subtract your 5 over. And we get x equals a 4. So as always, we want to go back and check. So when we go back and check, we get 4 minus 3 plus 4 plus 5. We're going to see if that gives us a 4. So this gives me a 1. 4 minus 3 is 1. 4 plus 5 is 9. So So I get 1 plus 3 equals 4, so 4 does equal 4. So our answer is checked. We get to keep that one. The one thing to be careful of, though, at this step here, when we divided by 8, you only want to do that if it actually divides into an integer answer. If it doesn't divide into an integer answer, you don't want to do that division step, because that's just going to make your life so much harder if you try to square a decimal or a fraction. Trust me. So just leave it at that point in time.